In this fourth video, we're going to solve logarithmic equations using various techniques. So let's get to it. Okay, so I have, first one, I have 3x is equal to log base 6 of 216. And one thing that you might notice, I don't know if you'll notice it or not, but 216 is a power of 6. So I'm going to rewrite this. This is my first technique, is I'm going to rewrite it as an exponential. Okay, so I'm going to say 6 to the 3x power is equal to 216. Well, 216 is 6 to the third power. So I have 3x is equal to 3 and x is equal to 1. So log base 6 of 216 is equal to 1. So x is equal to 3, so x is equal to 1. And if you use the change of base formula, you could see that the log of 216 over the log of 6 is indeed equal to 3. So you could find x that way. So this is another one, just like the one we previously did, because we know that 243 is 3 to the 5th power. We've seen that one before in several. 3 to the 5th. 3 to the 4th is 81 times 3 is 243. All right, so I'm going to rewrite this as 3 to the x minus 4 is equal to 243. So I'm still rewriting as an exponential, and I do 3 to the x minus 4 equals 3 to the 5th using the one-to-one property. X minus 4 equals 5, so x equals 9. Okay, so on this particular one, we have log to the base 4 of 4x minus 20 equals 5. And it looks pretty similar. I think I'm still going to start off by rewriting it as an exponential. I'm going to say that 4 to the 5th power is equal to 4x minus 20. So 4 to the 5th is equal to 4x minus 20. 4 to the 5th power is a big number, I think. Let me see. 4 to the 5th is 1,024. So 1,000, I was using my calculator. 1,024 equals 4x minus 20. I'm going to add 20. So this gives me 1,044 is equal to 4x. So x is going to be equal to 261. Is that right? I'm going to check on my calculator. Plus 20 divided by 4 is 261. I'm right. That's how you do that one. Okay, so this one is more of a one-to-one property, only it's written with logarithms. And how you know this is because the bases are the same. So since the log to the base 4 equals log to the base 4, then these are also going to be the same. So x minus 1 is going to equal 20, so x is going to equal 13. This is once again the one-to-one property for logs. And they both had to be log to the base 4. If one of them is different, then all bets are off. So here, once again, number 4, here's another one that's like that. Notice it's log to the base 9, log to the base 9. Since those are exactly the same, then 3 minus x is going to equal 5x minus 15. And I'm going to, most people don't bring this over, but I like to keep it positive. So I'm going to bring this one over. So I'm going to add x, and then I'm going to add 15 and add 15. So I'm going to have 18 equals 6x, so x is going to equal 3. And that's how that works. Okay, so these last two I'm going to leave for you to work. I would like for you to solve these two problems. That number 9 may cause you to think a little bit, but number 6 you're going to use the one-to-one property. So I want you to write these down in your composition notebook, and I expect to see them. It may be possible, or it may be likely, that you will need to copy these down onto an index card, or at least work them on an index card for a quiz grade. So have them worked and be ready for class. We'll see you then.